Our next speaker is Joona Heinikoski from Housemarque, where he works as gameplay programmer. And Joona is going to talk about what kind of tools you can use for successful alien invasion. Welcome, Joona.
Good evening, everybody. As stated, I'm Joona Heinikoski, and I work as a gameplay programmer. And I have a brand view of the whole project at Housemarque, what everyone is doing, because I have to interface between the programming side, the engine side, and the artist and design side. So I'm going to talk what kind of tools we use for creating our latest game, Alienation. Not all of you might be familiar with the game, so let's start with a short video which introduces the game. So as the video shows, the game is top-down 3D shooter game with a twin-stick shooting gameplay. And we are using our own Housemarque game engine, which doesn't really have any name. It's just the Housemarque game engine. We have been building the game engine over the years. Almost all of our games are using the same engine. But with Alienation, we created many new components for the engine. One of the biggest ones for me was the stated scripting engine, which is the scripting language and engine I used to create the gameplay for the game. The game is using the state-of-the-art PBR rendering, which is the same rendering model that, for example, Unreal Engine and Unity are using at the moment. And we have brand new GPU compute shader-based particle engine, which Jere Sanisalo was speaking earlier. And that is using our fancy FluidSim engine. But this is not a tech talk. This is about the tools we use to harness this power of our engine. As I am a programmer, I know mostly about the programming side, but I will show you bits and pieces about the artist side. Let's start with the art tools we used. Traditionally, people have used modeling software for creating 3D models, but these days it might be more beneficial to use digital sculpting tools like ZBrush. Our character artist used ZBrush to create all of our characters, and in his opinion, digital sculpting is way faster than traditional modeling. ZBrush here is very, very powerful. You can do almost anything you want, but it has a bit of a learning curve. There are some easier sculpting tools available, but they are not as powerful as ZBrush. But they might be free, so if you are looking into getting to 3D art, I recommend going to sculpting, because that is what enables you to fastly make organic shapes, but why not also non-organic shapes as our guns in the game. ZBrush is very fast when you know what you're doing, but it has no GPU acceleration, which is a bit of a bottleneck, because everything is rendered in CPU, the regular computing power of your computer. So very large scenes might get a bit slow, and you need to start working around that limitation. From ZBrush, the character artist moves the character or whatever he's working on to some other program for further work. And our character artist prefers Foundry Modo, where he does retopology, which means he takes the ZBrush model, which has millions of polygons, and does the topology on top of that to reduce the amount of polygons so we can actually use it in the game. Other thing artists have to also do is UV mapping and bake the texture maps to the shape. Modo is pretty new in our toolset, so we don't have all the tools available we need to get it actually in the game. But Modo is, in our experience, very modern and somewhat easy to learn, and it's very powerful for these tasks. But Modo doesn't allow you to do texturing, and for texturing and other 2D stuff, we use Photoshop, which is probably familiar to all of you. And in Alienation, we used Quixel suite for material design. As our engine uses PBR rendering, physics-based rendering, we need to have all the correct maps for there, and we need tools for that. But thankfully, the big engines are using the same rendering model, so there are good tools for creating the materials. And for Alienation, we used Quixel suite, which is a plugin you install in Photoshop. At this point, we have moved on from Quixel suite. We are using Painter software for that, which is a bit more modern, but Quixel suite is very nice way to start working with PBR materials, as it integrates in Photoshop, and most of the texture artists are familiar with Photoshop. Photoshop is, as a general purpose 2D tool, is used for other things as well. For example, HUD elements, and even I have it installed on my machine because I have to do some tasks involving 2D graphics. And after we have finished the materials, we need to bring the model to Autodesk Maya, which is a very, very long-standing 3D application. Housemarque has been using Maya or its sibling Max for years, and we have lots of scripts. For example, our very own exporting tool, which is actually the very only way you can get models from 3D software to our game engine. For Maya, Maya is also exclusively used for our animation. And here we can see the animation artist doing animations for the character that was created by the character artists. But in our experience, Maya is getting a bit old at this point, and is not as easy to use or as fast as Modo. And some new features are very hard to get into there. So you need a technical artist for Maya. Thankfully, we have very, very good technical artists. And in this picture, you can see here our few of our tools we use. For example, here we have the exporter tool, which is very important for us, because otherwise you couldn't get the models to our game. Some other companies are using more general purpose exporting, but we have our own tool that allows us to use the whole extent of the power of our engine. Other thing we need to also consider is that if you use some extra libraries, you might not have support for Modo. And in our experience, we used Havok Animation, and they only support Maya and Max and few other 3D software suites, but not Modo. So the exporting to Havok Animation system also requires us to use Maya. And from Maya, when we have animated the characters, they are brought into Havok Animation tool. We used to have our own animation tool, but it had very bad limitation, which was that you couldn't see what you were working on. So you would do the animation scripting, you would do all the animation blending, you would do all the transition effects, but you wouldn't know if it actually works. You need to export it, run the game, and actually play the game to see if your character is working as expected. What we wanted to have is a tool that has what you see is what you get interface. And Havok Animation tool fills that perfectly. In here, in the middle, you can see they have a preview image of your character running. And you build the character scripting for the animation with state machine-like interface. So the character is in one state and does state transitions. And you can configure blending and transition effects that works almost exactly in the game, similar to it works in the editor, which is very, very beneficial. Other thing you can do with Havok Animation tool and Havok Animation system is have I/O events. So from the gameplay side, I can send an event to the animation system. It does what it does. Character might jump. And then you can send events back, which is very good for me because I can know when the animation is actually finished. Otherwise, I would just have to guess what is going on with the animation. Our old system didn't support such things. And previewing is good, but still, Havok Animation tool is running on a different engine than our own, and sometimes this happens. This is supposed to be the character in here, but this is just text side. Then we look into our own engine and start working out the problem. What is wrong with the character? And to work with the engine side, we use Microsoft Visual Studio, which is probably familiar for all Windows programmers. It's an integrated development environment for Windows, and we use it for developing the engine side C++ code. One benefit of using Visual Studio is that it has very good SDK support. Our engine targets PS4. All the PS4 tools work with Visual Studio. We work with the Havok suite. All the Havok SDKs work with Visual Studio, so we are locked into this. But thankfully, it is very good for your work. It has good debugger, it has good code completion, and many programmers are familiar with it. So that's the tool we use for engine side code. But the tool I use is Stated Editor. It's our general purpose scripting language which we use for the gameplay side, or pretty much all the non-generic scripting. So we use it for gameplay, characters, level progression, and menus, and the HUD heads-up display system. The Stated Editor is written in C# using VPF and Avalandoc, so it has pretty good support for whatever you expect from a text editor. You can use tabs, you can move things around, you can customize the environment to your liking. And I have some needs I want from my text editor, so I can make it my own, work as I want. But the thing is that we have our own language, so let's go to that. So stated scripting language is based on ML syntax, which is a very old functional language, and we also have some influence from Python and Lua. When I came to work on the project, I had experience working with Python and Unity, so I gave my influence for that from that side. I wanted to have some nice things from Python and Unity C#, so we got them into the game. Stated language is, as stated, functional language. It has weak typing, but it's not object-oriented, really. We have tables, which we heavily use. It's hash map type tables, so you can write to any variable inside the table, any values you want, but not functions. So for functions, we have to work with C-style functions. So instead of calling object.doTheThing, you have to call object.doTheThing and give the object you want to use with that. A little bit more on that later. Stated is also based on state machines, similar to the Havok animation system. So characters are, and all the objects are in some state and do state transitions. For gameplay coding, that makes our work easier because I can see how the character logic goes. So they start from one state, they go to another, and progress logically as I work. So it's not just writing the script, it's also working on the graph that the character uses. In this example, we have pickup. The pickup starts from a spawning state, so it just spawns in the world, waiting for player to collect it. Then the player can walk close to it, and it shows a pop-up on the screen. So this is that state. And from that, we can progress to player collecting it or player walking away. So if the player walks away, we go through this transition and go back. Or when he collects it, we go here, show some animation for collecting it, and then destroy the object. In this example, we have a simple level script. This is a floor-based alien ship. So the level starts, then we have some beginning script, and then it has different stages over the level, and loops back to the beginning, and you go through another floor, loop back to the beginning, and in the end, you go through that. This enables even the designers and level designers to work their progression in a visual sense, not just writing their progression and how objects should work, but they can see it visually. Of course, you still have to write some script, what to do in the states, but this helps you visualize your concept. Here's a stated script example. As you can see, if you are familiar with Python, this might remind you of Python a bit, but also Lua. So from Python, we copied meaningful whitespace. You define the blocks by indentations. So here we start the block with the if clause, and everything that is indented for more than this is inside the if block, similar to Python. And then in a for clause, everything in here is indented, so it's executed on the for loops. Some people have issues with the meaningful whitespace, but I am from Python background, and I think it makes your code clean. It forces you to work with a clean code that is easy to read. Here we have the object-oriented like module calls. So we have a health module, which works as an object. The health module is running within the state machine itself, which is referenced with the self variable. So you give the health module function yourself, and the health module does what it's supposed to do. So first we check if the character is alive. Then we check something else, and then when you pick up this invincibility boost, we set character invincible for the duration of the time. In the design of the modules, some function calls are supposed to be called from outside of the character, like this health is alive. You can test if any object you have reference to is alive, but you can only set yourself invulnerable, so you don't need to pass the self variable to the invulnerability setting function. And instead that we have similar for syntax as Python. So actually all for clauses are for each. So it's a bit different from C, but very similar to Python. And this makes your code a bit safer. Originally, we didn't have a while clauses at all. We were only working with for, and that makes your execution very predictable. You know that you are not going to be in an infinite loop. But of course, there are some cases where you don't know how many objects you want to go through. And now we also have a while in the scripting language. And another thing that we use extensively in stated is message passing. You can easily spawn messages that anyone can receive, a bit similar to SQL. You can query for a specific type of message that contains the information you need. And for example, in here, this character is looking if someone is sending a message to itself, and if there is either invincibility boost or move speed reduce called for that character. Anyone can send these messages, and instead that we have made it so that you cannot actually touch anything from other objects, so you wouldn't make their state unpredictable. You can only change the variables in your own state machines. So you have to send a message for the other objects, and they have to receive it and react to that. What that enables us to do is have all the characters and objects running in parallel. In modern computers, and especially in PS4, you have 8 cores, and we want to enable all of those to run our scripting language. So instead, I don't actually need to do anything for having all the power of all the cores on the multi-threading setting, because they are automatically run in parallel, and we pass the messages to communicate with the objects. Meaningful whitespace is good in Python, but it's not always very well defined in our language. So in this case, I thought I was writing very good script here, so I just have multiplication going on in here, but for some reason, the compiler doesn't like it. What the compiler likes is it's adding huge whitespace in here. The reason is that it wants the blocks to be in the same level. So actually, I have to be next to this block for my multiplication. But if I change my script to look like this, then it works. With your own tools, it's sometimes a little bit cumbersome to come over these problems, because you cannot Google why I'm getting these problems. But thankfully, I can just go to the guy who wrote the compiler and ask him. And he usually has answers for me. And also, I think this forces me to write cleaner code because I have to respect how the compiler works. So everyone writes very similar code, and it's not difficult to read someone else's code because it's very similar to yours. Here are some examples from other objects. Here is an enemy character. So we have the logic running here. But the better example is our player character. One state machine can have multiple graphs, and we are using that extensively in the player character. In here is the gameplay logic. So we start from initialization, then go to generic running mode. The character can rush, so we go there and do all the things it has to do. And that is communicated to the other graphs. The other graphs here is very important, the melee system. It's controlled in here, and animation communication. This is, I'd say, even more complicated than just the gameplay side. We have a lot of code in here, but a lot of states in here. So the gameplay logic, reading from the controller, reacting to the player input, it's done with mostly code. But the animation system is done with state transitions because it's easier for me to see that, OK, he does this animation, moves to the next animation, moves to the next animation, and then always comes back here, which is the general moving module. Some other graphs we have, I have a huge transition here, which is a general systems that don't have any state changes, like running the health, running visuals, and other things. And then for our video from a few years ago, we also wrote a scripted player character, so I have one graph for that as well in here. But just looking at the object, if you're familiar with the system, you can start understanding how it works. It's not just reading the code, trying to follow the spaghetti where it goes, but you can just see that, OK, it's doing the state transitions. And hopefully, the programmer has even written some comments and descriptive names for your states and the transitions. But with your own tools, you can sometimes get this, and well, then you just have to exit the editor and hope that you didn't lose too much work. Stated compiler is a very important part of the project as well, because we have our own scripting language. We compile it to bytecode. So the compiler is created with F# language and fparsec compiler generator. We have integrated the stated compiler to the stated editor and our twister system, which builds the game. When I'm using the stated editor and working on my game objects, I can compile the character I'm working with and push it to the game live, and it immediately changes how the character is behaving. But compilers are a bit boring for the user. The interface is usually this. It says what it does, and you don't really affect it. You just throw some code in, and hopefully something meaningful comes out. But sometimes your compilers give you errors, and that's my main interface with the compiler. So I'm very interested when working with C compilers, how good are the error messages? I think the classic GCC gives very hard to read errors, but the CLang gives you better errors. So I'm going to show you a few error messages, and I give you 10 seconds to guess what the error does. So here we have a simple error, and it is a syntax error. In here, the programmer has used arrow left symbol instead of equals symbol, which when you are assigning values to the table definition. This is pretty good error. I can see immediately that in line 15, I'm using wrong symbol. But for some reason, the compiler says I should be using this symbol here when I actually should be using an equals symbol. Another good example is here, a simple error. 10 seconds for you to guess which one it is. It's a missing argument. So it's telling me that the function wants a string, number, and another number. And I'm just giving it a string and number. And for some reason, it has to repeat that. But I immediately know that I should be supplying a bit more arguments. And sometimes you get other errors, like this one. Keeps going, and here's the end. In case of this, it was probably a table access to undeclared identifier, but it didn't actually give me any more help. Where could I find the answer to my solution? So in case of this, I actually have to do a SVN revert. With your own tools, you get what you create. You might get your best tool for you, because you can really affect how it works. But sometimes it's not the most polished one, and it gives you bad errors. But this is very, very rare. I think I've gotten this twice. And the level editing is important part of level editor's job. And we come back to Maya here. We have created our level editor tool on top of Maya. So immediately we get the good editing tools from Maya, like moving, scaling, searching. So we don't have to work on those. So we have the Maya interface here and our own level editor here. And I'm not a level editor, but I enable the level editors to work on their levels. So my job is in the stated editor, define what functionality I expose to the level editors, and then they can use the level editor to actually push them into the game. And we even have a live connection system in our level editor. Similar to stated, you can have the game running in one window and Maya running in another, and work on your level, and immediately objects move in your screen as you work with them. This is especially important when you're working with the lighting. You can tweak the lighting values, how bright it is, and what it is the color. But unfortunately, that is not automatic. I need to actually enable the live connection for all the state machines, because we don't have a generalized system for this, and the state machine workflow might not be always the same. So for lights, I need to enable it. But for something like just a generic object, like a rock, I just make it so that it updates the transform of the object, and it's very fast for the level editor to work on the levels then. Some of you might have been working with Unity and setting up the collision layers. In Unity, I usually get like 5 or 10 collision layers, but that wasn't good enough for us. We wanted to have 64 layers, all the power of the 64-bit engine we have. So we need to set up the collision layers. So what we do here, we have different objects, and some objects need to collide with each other. For example, enemies in some states don't collide with each other, but they collide with the player. And this is the tool we use to set up those collisions. This is not Minesweeper. I created this tool because originally we set them up in code, but it was very difficult to read. So we needed to have something visual for this. In general, I think if you have a visual tool for your, even for programming problems, it gives you a better view of your problem and how to solve it. In this tool, I have to admit, it's pretty unmanageable to have 64 layers which can collide with each other. So I have some helping tools. When you highlight a collision somewhere, you get the highlights in the sides as well, so you can read the layers. Unfortunately, when we updated to Windows 10, the Windows UI changed a bit, and the checkbox is not as easy to read as in Windows 8, but not impossible. And next tool I'm going to talk is the game launcher, because you actually need to get the game running. And in our game, traditionally, you had a bat file that said run level 1, run level 2, run level 3. But for Alienation, that wasn't good enough. We wanted to be able to easily change the resolution when playing the debug version on the PC, and easily run the PS4 game. So in here, originally, you just have the drop-down menu for level, if you want to enable shadows or not, the resolution you run the game in, and if you want to run it on PC or PS4. But then the artist came in and wanted to have some extra features. When I implement a feature like player can die, I push it in the game, and the artists are good. Now the player can die. But 5 minutes later, they come back to me and say, hey, I'm dying all the time. Could you create a cheat for me? And I put them into the launcher. so you can have the God mode on. This is a very simple Python program. We actually just set the started arguments for the game when we launch it. But it enables us to fast iterate on different things. You can, for example, force a player level, use different armors for the characters, even join online games, which is very important for me when working on online mode. And this has been invaluable tool, really, for me and whole team to enable us to quickly iterate on the game. A few more tools we use. For our audio, we use WWISE. And that comes with its own audio studio. I'm not the audio guy, and I was very intimidated by this. I know something about graphics, but nothing about audio. And a few weeks ago, I was in a situation where I needed to work with audio. So I fired up WWISE and started working with it. And I found out this is actually a pretty easy-to-use software. You can set up audio events, audio effects, and even do a little bit of audio scripting, similar to the Havok animation tool. I think WWISE is very powerful, but surprisingly easy to learn tool. And their audio engine is very powerful as well in the game side. And last tool I'm going to show you is Sublime Text, or really any text editor. Text editors might be the most boring things you have on your computer. And we have some fancy editors we created, like the stated editors. We have the Visual Studio, Microsoft developed tool. But still, you need to have a good plain text editor, because it can solve problems that other software can't. For example, if our stated file corrupts for some reason, SVN merge gone bad or something, I can always open the file in my text editor and see what the problem is, because the text editor doesn't care what your text is about. You can just edit it. Some other editors make assumptions of that. And it's very fast. My favorite thing about Sublime Text is that you can select multiple lines and work on them. I could set up a Python script, but that would take more time. I can just edit multiple lines at the same time. Of course, it has a powerful search, and in my opinion, it's pretty beautiful as well. And those are most of the tools I want to talk to you about. And if you have any questions, I would be happy to answer them. I'll set up a small slideshow showing of the tools while I'm answering your questions.
Hi. I hope this is sort of like a lapse of thought on your end, but you mentioned at one point we had this really the awful compiler bug message that you did an SVN rollback. You're not actually using Apache Subversion for your version management.
We are using subversions because we have huge scene files, art files, and on JIT, because you have the distributed model, you actually have all the data you have ever created on all the computers. And if you have art assets that might be up to 1 gigabyte of size and all the history for those, it would take a lot of space in your small SSD. We are actually looking into working with JIT on our code side or all the text files. But for now, we are working with SVN because of the art assets.
Okay. So the reason there's not just laziness.
No laziness. It's the art assets, really.
Okay, well, thank you.
I saw on the state graph that you had colors. Do they have any meaning, like right up there?
Let's pause it. So the state graph is actually, you can have colors, but they are just like comments. For my convenience, I have marked all the melee logic red, but it doesn't affect the behavior of the character at all. But in here, the two main states are running here and behavior running. I marked them with this green color, so I can easily find them. But it's just for reference, not any behavior.
OK.
Any more questions?
OK, cool. Thanks for your interest in tools.
Thank you, Joona.